For today, I will showing you how to express these numbers in its polynomial notation. Okay. So you have always to take note that any numbers, especially the integers part, has a corresponding weights and exponents when it is expressed on its base. So this one is base 4. So we know that this number would be expressed in bases of times 10 times 4 to the certain weight. Okay, so we can write this one as 3. Start with the ones place, that is 3. That is times 10, so that is times 4. And then its weight is at ones place, so that means it is based on 0. And then plus, that is 2 times 4. And then the next is the hundreds place, but it is not 100 in terms of base 4 na number system, but it is analogous to the hundreds place of a decimal notation. So you have 2. So location ito ay times 4 to the 1. And then plus you have last number is 1. And then you have times 4. So this is 0, 1 times 10, 4 to the 2. Okay. So this is 1 is its polynomial notation. And then to identify its decimal value or the decimal number system value, you should be able to calculate this one. So this becomes 3 times 4 is 1. 4 to the 0 is 1. And then 3 times 1 is 3. And then you have plus 4 raised to 1 is 4 times 2 is 8. And then plus, that is 4 times 2 is 16, right? 16 times 1. Okay. So its decimal value should be 3 times 16. 3 plus 8 is 11. 11 plus 16 is 27. Okay, so 27. So your answer is 27 base 10. Okay, so 1, 2, 3 base 4 is equals to 27 base 10. Okay, so that is your answer if you are asked to find its decimal number system value. When you are asked to find its polynomial notation, then you should be stating as 3 times 10 to the 4 plus 2 times 10. Sorry. So my bad. 3 times 4 raised to 0 plus 2 times 4 raised to 1 plus 1 times 4 raised to 2. So this one is your answer. So this is your polynomial notation, and this one is the base 10 equivalent. Okay. Okay. So let's proceed to number 2. Number 2 states that 3, 5, 6, and then base 8. Okay. Base 8. So try to express again, it's in polynomial notation. So this one has an exponent of 0, this one an exponent of 1, and this one has an exponent of 2. And then they are always raised to base of 8. Okay, so you could write this one as starts with the ones place. So that is 6 times 8 raised to 0 plus 5 times 8 raised to 1, and then that is plus 3, that is uh, 3 times 10, or 8 rather, to the 2. Okay, so your answer for polynomial notation is this one. And then for its decimal equivalent, we can have that is 8 to the series 1. So this becomes 6 plus it is 8 times 1 is 8 times 5 is 40. And then 8 by 8 is 64. And then we have 64 times 3. So we have 64 times 3. So we have 192. We have 192. And the base 10 equivalent is 6 plus 40 plus 192 is 238. Okay, 238. Okay, so your answer should be 356 base 8 is equals to 238 base 10. Okay. Okay. So that is the proper way of uh, getting the decimal number system of a number of any base and expressing its polynomial notation. Let's try number 3. Okay, so number 3, that is 1001, and then you have a point of 1101 base 2. So this is a binary system. So we need to express this one in polynomial notation. So let's try to find its weight. Weight nito, this is 0, 1, 2, 3, and 4. This one, sa fraction na part, this is -1, -2, -3, and -4. Okay. Okay, expressing its polynomial notation, start in the direction from the farthest decimal point to the whole number or to the integer part. So we can write this as, so all are base 2. So you have 1 times 10, sorry, that is 1 times 2 to the -4 plus, we've done this one, that is 0 times 2, -3, plus this one, that is 1 times 2 raised to -2. This one is plus 1 times 2 to the -1. The next we have 0, 0 times 2 to the 0 plus 1 times 2 to the 1 plus 0 and 2. So that is 0 times 2 to the 2 plus, this is 0 times 2 raised to 3. And then we have plus 1 times 2 raised to 4. Okay, so that is its polynomial notation. So to find its decimal value or base 10 equivalent, we will try to evaluate each part. So 1 times 10 to the -4, that is 1 over 2 over. Okay, so try to compute. So you have here a 1/16 plus, this becomes, so 0. Then this one, that is, this becomes 1 over 4 plus this becomes 1/2 plus this becomes 0 plus this one is, that is, that is 2, right? 2 raised 1 is 2 times 1 is 2 plus this is 0 plus, and then you have also 0 plus 2 to the 4 is 16 and times 1, so that is 16. Okay, equals. Okay, so you need to add up. So we have 1/16, or that is can be expressed as 16 to the negative 1 plus 0 or plus 4 to the negative 1 plus 2 to the negative 1. And what other numbers? What plus 2, then plus 16. So your number should be 18.8125. 18.8125. So that is your answer. Okay, so that is 1001.1101 base 2 is equal to 18.8125 base 10. Okay. Okay, so that is the way on how to get the base 10 equivalent of any numbers of any bases and expressing its polynomial notation.